Hi, my name is Erynn. I'm going to be doing a couple problems for the next phase of the JADE application interview process. I just wanted to quickly explain kind of why I do things the way I do it, because I know it's a little different than the majority of online teaching videos these days. I choose to do kind of the old school way of a document camera. I feel like it's awesome for the kids to, one, be able to see me writing it down and at the speed of it takes to write something down. So I feel like that's really important and helpful for making it applicable video for them. The other thing I love the document camera for is the calculator. I've noticed over the years in the classroom and teaching online too that kids just don't know where the buttons are and what kind of functions that their calculator can do. So actually having the calculator under the screen, being able to show them exactly what buttons to push is really helpful for them committing that to memory on how to utilize their calculator the best. The other thing I love to do is kind of model what I preach, right? I always tell them that they need to get a piece of paper out and write this down, and that's the best way to learn math. So I want to be able to practice what I preach. And then last but not least is the video of me in the corner. The feedback that I've gotten for kids is it's just more relatable for them to see who's talking to them, have that visualization. And also, it's a little bit better than just a voice and a black screen with some writing on it. So those are a couple of reasons why I've chosen to do things the way that I do. And I hope you guys can appreciate that and enjoy my video. So, all right, here we go. Thanks so much. All right, we're going to do a couple problems today. First things first, guys, always get out a pen and a piece of paper. You want to be able to write these things down as I'm doing them as well. Nice thing about the video is you can always pause, rewind, and re-watch whatever you need to if you don't really understand something or I'm going too fast. So please utilize that for sure. The analogy I always give my students is I can't watch somebody play football and go out and then play football and be really good at it, right? Same thing with math. You can't watch me do math and then go out and do math on your own, on your test or whatnot, and know how to do it. So this is your practice. Get out your paper, get out your pen or pencil, get a calculator, and let's do some of these questions together, okay? All right, so the first question that we're working with is calculate the following sum. 99 minus 98 plus 97 minus 96 plus, this means all the way down to 3 minus 2. So I could write all these numbers out and add them together, but that would take a long time. So I want us to try to think of something a little bit more relatable, smaller, manageable. So I'm going to talk about, let's do 7 minus 6 plus 5 minus 4 plus 3 minus 2. I'm going to do the whole set. That's the reason why I'm choosing a smaller set, so I can do the whole set, okay? Is there some way I can add these and make a little bit of a shortcut instead of going from, left to right? For me, I'm kind of seeing groups. So if I group these numbers, that's 1, 1 plus 1 plus 1. Well, heck, that's a lot easier, right? That's 3. So we can take this method and apply it to something up here, okay? But again, we don't want to write it from 99 to 2. So let's think about how we can make this simpler. So what about if I take how many groups I have? Okay, so I had a number from 7 to 2. So let's do 7 minus 2. That's 5 digits. Let's see if we have 5. 1, 2, 3, 4, 5, 6. So not. The reason why it's not 5 is because this set includes the 7 and the 2. So in order to get the correct number of digits, we need to add 1 to it. So that means there's 6 digits. Okay. There's 3 groups of 1 because I took every group and divided it into, took a group of 2, right? So I want to divide this by 2. So that's 3 groups of 1. So that's it. We just have to do 1 times 3. Now, with everything in math, we can make this more relatable by looking at an easier problem to solve a harder problem. Try this in algebra. It works a lot, especially when you're working in upper level algebra, trig, all that good stuff. Try to think about something more simple that you learned in pre-algebra or algebra 1 to utilize to help solve the problem. So let's look at this. So we talked about the number of digits. So let's find out how many digits are between 99 and 2. We're going to do the same method. We're going to do the first number, 99, minus the last number, 2. So 99 minus 2, we get 97 digits. But we're including that 99 and 2, so we need to add a 1 because it's inclusive. And now we're going to divide by 2. So we get 49 groups of 1, right? Because 99 minus 98, 97 minus 96, 3 minus 2. So that's it. 49 times the sum of my group, and in this case, it's 1. The sum is 49. Easy enough, right? All right, so let's look at this last problem I have here. With all geometry questions, guys, please make sure you're drawing out the figure. I know it takes a little bit of time, but it's so much easier when you can write on that figure and make marks on it, okay? So let's look at this one. A right cylinder of a radius 2 is removed from a cube whose edge length is 10 centimeters. What is the total surface area and volume for the remaining solid? For simplicity, use pi equals 3. So let's go ahead and label what we have. So we know the sides are going to be 10. So I have the length, the width, and the height. I'm going to label those all 10 because it's a cube and all sides of a cube are equal. And then it says the radius of my cylinder. So this guy is going to be, just going to make a little arrow, 2. Okay. So we want to talk about surface area. So I like to draw little shapes by my oh my gosh, by my abbreviations. So it's a little bit easier instead of like, losing what I'm talking about. So I'm going to talk about the surface area of a cube first. So that's kind of my notation for surface area of a cube. In order to find the surface area of a cube, we need to find the area of each square. To find the area of a square, it's length times width. But how many squares do we have in a cube? Top, bottom, front, back, side, side. So we're going to multiply this by 6. So in order to get the surface area of my cube, I need to do 6 times L minus W. But on the top and the bottom, there are those circles, right? So I need to subtract the area, or the surface area, doesn't matter, surface area of a circle. Same thing as, because it's a 2-dimensional figure, so surface area and area is the same for this guy. So it's going to be pi r squared. But how many of those do I have? I have 2 of those, so I need to multiply by 2. Okay, but think about this. What other surface would I have if I cut out a cube in a cylinder in a cube? So I have this handy dandy cube here. So let's think about this. Oh my gosh, I just said cube again. I have this handy dandy cylinder. This is a cylinder. So we need to talk about this inside piece, okay? So if I cut this out of my cube, I could touch this inside of the cylinder. So we need to take away that piece, okay? So we need to add it, because we could touch that. That's another surface. So we need to add the surface of this cylinder. And we're talking about only the side of it. So remember, that's called lateral area. So we need the lateral area of the cylinder. So the lateral area of this, now let's think about this. If we had a cylinder, here's my cylinder, and I wanted to unwrap this, it would become a rectangle, right? So I have the height of this rectangle would be equivalent with the cube height. But what about this length here? If I made this into my cylinder, it's a circle. So it's the area outside around my circle, which is also known as the circumference. So the area of this square piece, so let's go ahead and kind of draw this down here so you can see it a little bit better. I would have the height of my cone. And then this length here is going to be the circumference of that circle, this circle, which is 2 pi radius, which is 2, right? So I'm just going to make that a 2. All right, so I'm going to add the lateral area of this cylinder, which is this rectangle. So the area of rectangle is length times width. So length is going to be my 2 pi 2, and I'm also going to multiply it by my height. Okay, well, let's do this. Let's do 2 pi r times height, because this has all the formulas with variables. So let's kind of continue that. And then we'll add it all up. Okay, so now let's take each piece of this. So this one, we're going to do 6 times length and width. So 10 times 10. So 10 times 10 is 100 times 6. I'm going to get 600. So this is 600. And I'm going to take away, let's do this part. So pi r squared times 2, because there's 2 circles. They said for simplicity to use pi as 3. So let's plug that in. Our radius is 2 squared. When we think about order of operation, we always do the squared first. So we're going to do 3 times 4 times 2. So 12 times 2, we get 24. So we're going to take away 24 there. Okay, and then let's do this lateral. So what we did over here already. I'm going to just rewrite that. So 2 pi, we said is 3. Radius is 2, and then the height is 10. Okay, so let's go left to right. So 2 times 3 is 6, times 2 is 12, times 10 is 120. So we're going to add 120. All right, what do we think so far? If we add all these digits together, we're going to get 696. And then we need the units. When we're talking about area, it's always squared. So centimeters squared. So this is going to be the surface area of this figure here. Okay. All right, now let's look at the volume. So volume's a little bit easier. If I wanted the volume of this figure, I could do like, let's do the normal, let's do the cube. Okay. As if this thing didn't have anything cut out of it. I'm cutting out a cylinder. I'm taking it away. So minus the volume of a cylinder. And that's going to give me my overall volume. Okay. So there are specific formulas that we can remember for volume of a cube and volume of a cylinder. However, we can also simplify that, which is kind of what I do because I'm not a big fan of memorizing a bunch of stuff. Volume in generality is area of the base times the height. If your prism goes straight up and down, like if I were to take my hands along the base, let's assume that this is a filled in figure. Hands are on the base and I'm going up. I'm not moving my hands in at all, right? So if I just go straight at the bottom and move it up, it's area of the base times height, period. Doesn't matter if it's a cylinder, doesn't matter if it's a cube, it's always going to be that type of thing, okay? If it was, let's say, a cone, if I was at the base and I was going up, I'm not going straight up. I have to kind of take my hands and gradually get them to go together. That's going to be area of the base times height. And then you have to multiply by some scale factor to take in the fact that we're going in. Same thing with a sphere. If I'm at the bottom and I'm going around, I'm not going straight up. So I'd have to take into account. So that's where the 1/3 comes from with the cubes and the pyramids, and the 4 comes in with the sphere for volume of the sphere. And if you're unsure of what those formulas are, that's totally fine. We can go over that in another video with those 1/3 and 4s. Okay, so don't let that confuse you because we don't need it on this problem. All right, so let's look at the volume of the cube. So we're doing area. So I just remember volume equals area of the base times height. That's easy enough, right? Okay, so for a cube, we're going to do volume area of the base. Well, the base is length times width and then times the height. So that's going to be for our first guy. Then we're going to do for our cylinder. So our cylinder is going to be area of the base, which is a circle, pi r squared, and then times the height. Okay. Now let's go ahead and put in our values here. Okay. So again, length times width, we're at 10 times 10 times height, 10, minus simplicity. They said to use pi as 3. So let's plug in a 3 there. Radius is 2 times the height of this cylinder is 10. Okay, easy enough. Let's add them all or compute this out. So 10 times 10 times 10, that's 3 zeros after 1 minus, we'll get this value. Remember, order of operations is important, so we have to do the squared first. So we're going to get 3 times 4 times 10. 3 times 4 is 12 times 10, that's 120. So 1,000 minus 120, that's 880 centimeters. We're talking about volume, so it's going to be cubed. There it is, guys. I hope that helped a little bit and made it a little bit more simple for you guys. If you have questions, don't hesitate to reach out, ask your teacher, comment underneath the video, and we'll get you the help that you need, okay? Thanks so much.